Right now, we're beginning the topic of behaviorism, and this is a kind of a mechanical approach to thinking about personality, more so than we've had in the past. And this model suggests that we're all products of rewards and punishers in the environment. That if we can know looking at this man, if we can tell which light bulb is lit up, we can tell exactly what direction he will take. And so our actions are all observable, Skinner would say, and they are predicted by the consequences of those actions. And so here's a little look at where we've been. We started out with Freud and the psychoanalytic, and Freud suggests that we do things because of our id, because of our unconscious motivations. The neo-analytics, including initially Jung, suggesting that we do things because of our personal and collective unconscious, but then moving into people like Adler and Horney, both of whom play great importance on the social environment. Erikson as well, were shaped by those social forces. We looked at biological theories, the ways in which our genes and hormones and biology cause us to act and behave in certain ways. We looked at trait theories, suggesting that we have these entrenched characteristics that lead us to behave in certain ways in a predictable pattern. And we haven't yet talked about cognitive theories nor humanistic theories. We'll come to those later. So for right now, we're going to look at behaviorist theories. Rewards and punishers made me do it. And as always, we want to look at Navajo perspectives along with this, and those kind of insights and comparisons are always valued. So behaviorism is the only scientific perspective on personality, according to Skinner and the behaviorists. The behaviorist line of reasoning goes something like this. You will have read about this perhaps in Feist. So premise one, we acknowledge that science draws conclusions only from what is observable and measurable. And that's a basic understanding of science. So that's not a disputable statement. Premise two, psychological constructs cannot be observed, but only inferred from behavior. We talked about that a little bit in our last chapter. And so if these two premises are true, which I think we have to agree to, we would say that to be scientific, any theory, must rely only on what can be directly observed, which are behaviors. The antecedents of those behaviors are what happened before, and the consequences of those behaviors, what happened after. So that's where Skinner starts off from. So what is personality to behaviorists then? So we would consider personality to consist of predictable, observable, learned behaviors. So by systematic and predictable, we respond in predictable ways to any given stimuli. We don't want to include the term in the definition, but what that means is that people around you and you yourself can predict how you're going to react in a given situation. We come to expect certain behaviors from some people. We'll give more examples in class, but maybe you can think of someone that you've just started texting, and very quickly we get a sense of how long it takes another person that we know to respond to a text message. We learn their habits very quickly. So that's kind of what we mean. That's just one example. And then observable, we can only measure what can be seen directly. We do not know what any other person's emotion is. We can infer their emotion from their behavior. Their face flushes, they tighten their fists, we can infer anger. But we can't see that emotion. We're only inferring it because of what we have seen. And so to behaviorists, personality just consists of these behaviors that we can see. We'll just consider these, we'll call them predictable, observable behaviors. Responsibility. So we can see this in other people. We can observe responsible behaviors, like if it's you doing what you'll say you do. Are you that kind of a person? Being there even if no one takes attendance. Consistently behaving responsibly. Is that observable patterns that we see in yourself or in others? And, I would say yes, we come to depend on people and not depend on other people based on these behavioral habits. So we can certainly observe those, and we come to depend on those routines. Self-control. We can observe self-control in someone avoiding the impulse to steal, waiting for their paycheck, treating others well, reacting calmly when someone is rude. Once again, we come to depend on people based on their level of self-control. We know who to go to, who to ask, and who to stay away from if they lack self-control. So in both of these examples, we might ask the question, are these observable behaviors the same then as traits? Or is there a difference? And we also ask, are we born knowing these things? So is this innate? You either have high responsibility or low responsibility. Innate, you have high self-control or low self-control. Or if not, then where do they come from? So these are questions asked by the behaviorists. So what do the behaviorists say? Well, some general premises. First off, you can see the rats in the mazes because a lot of Skinner's initial work, was with rats or with, at some point, pigeons. But all this work is applied to humans. So first off, behaviorists reject introspection and the whole idea of mind because we can't see mind. We can see brain. We don't know everything about the workings of the brain, but mind, that's something different that we cannot even see. So behaviorists reject that. They say introspection is useless because none of that is scientific, none of that is observable. So all behavior then, these behavioral habits that we infer to be personality, is determined by contingencies. And by contingencies, we just mean rewards and punishers. Like this reward is contingent on you engaging in this behavior. Your paycheck is contingent on you going to work. All behavior is determined by contingencies. So this kind of gets at some critique of Skinner early on, although we shouldn't. But what it does that some people don't like about the Skinnerian model is that it portrays humans just as intelligent rats running mazes in response to environmental rewards and punishers. So that's a perspective. And very often this is studied empirically, not in a natural setting, often in a laboratory, and that's to gain systematic evidence of these behaviors. And of course, Skinner began and spent much of his career on animal models. And he disputes, Skinner and the behaviorists dispute the notion of enduring disposition. They say, no, these aren't traits. You go to a different environment, a different set of contingencies, you will behave differently. And you also know that behaviorists reject the idea of free will. If everything you do is a consequence of a reward or punisher in your environment, then there is no free will. So that's along with Freud, who also disputes the idea of free will. But in Freud's case, he attributes behaviors to id, and in the Skinner's case, these are attributed to rewards and punishers. So habits are the foundation, the creation of these learned behaviors. And he says habits are good. Why do we create habits? Well, we want to reduce anxiety, or we want to maximize pleasure. He would say that's it. We have these habits. The habits become you. The habits become me. The things we do every day and repeat become what we are. And so how are habits learned? Well, we're going to talk about classical conditioning and operant conditioning. And classical conditioning is just learning what predicts an outcome. So not that you're causing anything, you're just learning what predicts an outcome. And we'll talk about Pavlov's dogs, the dogs who learned, when they heard a bell, learned to salivate because they then expected food. And operant conditioning, you can see the key word that's different here. In operant conditioning, you are having an active role because you've learned what produces an outcome. And so, you get your cue, it's 3:30, you have this routine, and you get this reward. You are producing the outcome by going through that routine. So that's the kind of the difference. We'll clarify them in the slides. But we'll talk more about habits here. So habits in the brain, we know some things about, and I'm going to give you an example in the form of a metaphor. So we know through Hebb's law that neural networks form and strengthen through repeated use. Hebb's law is that second one, neurons that fire together, wire together. And so anything that you do habitually is creating and strengthening neural pathways. And as we strengthen neural pathways, they are more likely to fire again in the future. The metaphor that we'll offer is, imagine that you're walking on a beach, and these are your footprints. And if you just walk on this beach one time, pretty shortly this water is going to wash those footprints away. Similarly, if you just engage in a behavior one time, it's not going to forge a new pathway in the brain. But the more you go over the same pathway, the deeper those grooves are, and now it's going to take a lot more water to wash that pathway away. Likewise, in the brain, the more you repeat a habit, having a cigarette with alcohol or something like that, the more that becomes deeply ingrained and harder to step away from. And finally, even worst or strongest of all are neurons that fire in conjunction with emotion. And so if there's a very strong reward, like the optimal things that give us the greatest pleasure, or a very serious punisher, like getting thrown into jail or something, both of those would be big emotion, and that would really enhance these pathways, such that it might be the equivalent of a big highway going along this beach here, and you can think of how much water it would take to wash out this highway. And similarly, in your brain, the more you repeat a pathway, and especially if you repeat it with emotion, the more entrenched it becomes, the more like part of who you are, or like your personality. It's like, to get rid of this highway, you'd have to really have some serious action, because you've now forged a really deep pathway in your brain through these habits. And just so we once again familiarize ourselves with the limbic system, we do have the amygdala, which is the emotion center. So this is where we're having action during strong emotion, and we have that right adjacent to the hippocampus, which is where memories are formed. And so the proximity of these two in particular is what makes the important point that when you have a habit forged with emotion, it's going to become a stronger habit, deeply etched in memory, and memory with an emotional foundation that is difficult for you to cognitively override. So the key topics in this chapter include the basics of classical conditioning with Thorndike and the law of associations, then Pavlov and conditioned responses in dogs, Watson, little Albert, and Skinner and conditioning in pigeons and rats. We'll then continue to operant conditioning, that is learning that you can produce an outcome, focus mostly on Skinner, and then finally observational learning, also called vicarious conditioning, and that's the work of Bandura. Just a little bit of him. We'll finish most of his work in our chapter on cognition and personality. So classical conditioning, learning that one can predict a response or a consequence. Ivan Pavlov, living back in the 1800s, a physiologist who was interested in bodily responses. And his work for his Nobel laureate in 1904 was on digestion. That was his main interest when he started this work. And he was a scientist throughout his lifetime. Because he was studying digestion, he was studying dogs' salivary chemistry, noting that dogs salivate, in response to and anticipation of food. And so because they would salivate, even in response to anticipation of food, he called these psychic secretions. So he is the one who informed us of the conditions for conditioning and the unique personality differences that influence learning. I want to just revisit this fourth bullet point, the salivary chemistry. So saliva has a physiological benefit. It's necessary has enzymes in it that help us digest food when it enters our mouth. And so it has a reasonable function, and when a dog sees food, we would expect the dog to salivate. Helps its body digest the food. But What if there is no food? What if all the dog has done is heard a bell, and that bell the dog has learned tends to ring before food comes out? Or the dog hears the refrigerator open and then begins to salivate. So that is not a natural phenomenon. Salivation when you see food is natural. Salivation when you hear a bell or hear the refrigerator open is not natural. And that's where this psychic secretions comes from. So let's look then. The dog naturally responds to food. So here's our dog. There's the food. The dog sees the food. The dog salivates. This is all natural, to be expected, beneficial, healthy, and that's the unconditioned stimulus. Now, in all of these models, conditioning just means learning. So we'll just leave that there for the minute. And we call it the stimulus. So the food is an unconditioned stimulus for the saliva, meaning that this happens naturally. Nobody has taught this dog to salivate in response to the food. It's unconditioned. And the response is also unconditioned. And so this is just a natural beneficial phenomenon. But then the dog learns what predicts food. And in this example, I've got the dog, and now we have the food kept in this cupboard that has a distinctive squeak. I don't know if you'll hear it in the recording, but when I hover over it, it sounds like this. All right. And every time the dog hears this particular squeak, then he knows the food is coming. The can is open, the food's in the bowl, and there comes the food, squeak, food, and we have this response, the saliva, in response to the food. All right. So then the dog learns what predicts food. So here's the dog, here's the cupboard, and there's no food. But the dog still salivates. So this is no longer a natural reaction. It's not a natural reaction for a dog to hear that and produce saliva. But because the dog has learned what predicts food, which is the squeaking cupboard, the dog salivates to the prediction, even though that's not a natural and learned response. And so we call it the conditioned stimulus is the cupboard squeak, meaning it's the learned stimulus, what the dog has learned, and the conditioned response is the saliva. So now we no longer have a natural relationship, we have a learned relationship. And so now the factors that influence classical conditioning. So first off, timing. So these acronyms CS and US, conditioned stimulus and unconditioned stimulus. So the timing, I'm going to give you some examples of these. So first off, the conditioned stimulus has to be before the unconditioned stimulus, not at the same time or after, because it has to provide new information. But let's look at what this means. So these are the factors we're going to look at in the subsequent slides. The conditioned stimulus has to be close in time to the unconditioned stimulus. Again, we'll look at this. So first thing, factors that predict the conditioned stimulus is timing. And so let's imagine that we have the cupboard squeak, and then a long time passes. Half hour, hour, and then comes the food. Is the dog still going to salivate in response to the cupboard? Will the cupboard serve as a conditioned stimulus in this circumstance? And the answer is in fact no, it won't. Too much time has passed. There's not enough of an association between the cupboard squeak and the food. So we know timing. If you're going to learn something, there has to be close in time to the conditioned stimulus, the cupboard, and the unconditioned stimulus, the food. So now here, this is a new example. Let's imagine that the dog has already become conditioned to the squeak of the cupboard. The dog hears the squeak, and the dog salivates, even if there's no food. Let's imagine that this is learned. And now you begin to turn on a light at the very same time as you open the cupboard. So the question is this: will the light alone, in this set of circumstances, serve as a conditioned stimulus? Will the dog salivate in response to the light if it has already learned to salivate in response to the cupboard? And the answer is, once again, yes, the dog will respond to the cupboard. No, the dog will not respond to the light. Why? Because the light has not provided any additional information. The dog had all the information it needed from the cupboard, so the dog is not attending to this light. This is called blocking. The existing conditioned stimulus, which is the sound of that squeaking cupboard, that's the existing conditioned stimulus, and it blocks the new conditioned stimulus, or the new attempt to have a conditioned stimulus, which is the light. It's blocked because it doesn't provide any new information. So what about the sequence then? What if we have the light first? The dog already has learned about this cupboard, and the dog already salivates in response to the cupboard. And so now we add a new step. We first turn on this particular light, then we open the cupboard. All right, and the dog salivates. But in this situation, will the dog salivate just to the light? And the answer in this case is yes. Why? This light has in fact provided new information. It's an added cue. If these things occur close in time, light, cupboard, food, the dog is going to learn that routine. It's called second order conditioning. If you add a new predictor that comes before the existing predictor, or I should use that word stimulus, a new stimulus that comes before the existing stimulus, that will be learned, second order conditioning. What if there's a similar stimulus? What if the dog has learned that this cupboard predicts food, and it sounds like this, and now there's a squeaky door outside, and it sounds kind of similar, maybe kind of similar. Will the dog salivate to this new squeak if it sounds similar? And the answer is yes, if it's similar enough. That might not be similar enough in this example, but the answer is that yes, the dog will respond to a second stimulus even if it never did predict food. It's called stimulus generalization. The dog generalizes this squeak to be any squeak predicting food. But how long will this phenomenon work? How long will the dog continue to respond to this with saliva? And after a while, no, the dog will stop responding as soon as they learn that this squeak doesn't predict food, but this squeak does. The dog will stop salivating to this second kind of squeak. This is called stimulus discrimination. So the dog has discriminated between these two kinds of squeaks, teased apart the pathways in the brain, been successful. What about when the unconditioned stimulus is removed? So let's imagine that we have the cupboard, and consistently it predicts the food, and the dog has learned to salivate. We now have this unconditioned response all set up. The dog salivates to the cupboard, but now we move the food to a different location. For how long will this dog continue to salivate to the squeak of the cupboard, which no longer predicts food because now the food is kept in a bin, How long is the dog going to respond to that cupboard? And after a while, we'll look at some schedules. No, the dog won't respond anymore once this unconditioned stimulus is removed. So it might take a while. And we'll look at, I think coming up right now, this is called extinction. If there's enough squeaks of this cupboard without food, that reaction of saliva will stop. And we'll look at the schedule at a later slide. And so then, after a while, the dog stops salivating because the food is no longer there. But what if we return back and we start putting the food in this cupboard again? That response will come back fairly quickly. Now we've added the food back. Now we have the squeak-food relationship again, and we're going to get a spontaneous recovery very quickly of the saliva in response to the cupboard. And so we have a short little video that I can't embed into this because of the limitations of PowerPoint recording, but this will be posted up for you. And this shows all of this quite well. And so this is the schedule I was mentioning to you. So let's just orient to this just a little bit. All these drops of blue, they represent saliva. On the bottom x-axis, we have trials, like the number of times these things have been paired. We're talking about conditioned stimulus, unconditioned stimulus pairing, that is, pairing the cupboard door with the food. And so it takes, for example, there's a little saliva, and then after the second time this happens, you get a little saliva. The fourth time, you get more. So on the y-axis, we have the drops of saliva. So not very much at first, and we see this quickly building up. By around the fifth trial, we see a lot of saliva. So it doesn't take long. So 10 drops of saliva just for the sound of the cupboard. And now we have a habit. Now this dog is salivating consistently, 10, 11, 12 drops of saliva just in response to the cupboard. And it only took, you can see here 4 or 5 trials to get there. Now what happens when we move that food to a different cupboard? In other words, we have now the conditioned stimulus, the squeak of the cupboard, but no food. We have a quick drop off in the saliva produced. The dog learns quickly, now this isn't getting me food anymore. Now let's let some time go by. All right, so now we've been doing these for several weeks. Now we're just going to let some time pass. We're not going to open that cupboard at all. What happens then when we open the cupboard again, the conditioned stimulus alone? Well, look at that. We get a shoot up of saliva, even though the dog had learned that the cupboard wasn't predicting food anymore. That still is deeply trained in the brain that we have a recurrence of all of that saliva, and then it fades out again as the dog remembers, oh yeah, there's no longer food there. So this is an important kind of a chart for understanding these relationships, not just for dog training, these generalized to our own experiences, as a point I'll hopefully be able to make. All right, so understanding conditioning. So classical conditioning relies on our natural taste buds. As you look at this lemon, do any of you, like me, feel a little bit of saliva pooling under your tongue, maybe toward the back, just looking at this picture of a lemon? Now, if that happened to you, my friends, there is no lemon here. There is no lemon. And so if you just produced all that saliva, that is a conditioned response, anticipating lemon. And so unconditioned just means naturally occurring. Nobody taught you. Nobody taught your mouth to produce saliva when it sees a lemon. Nobody taught you to jump when a loud noise happens right next to you, or, to shy away when you're yelled at or shamed. Nobody taught you those things. Those are all unconditioned. They're naturally occurring. The law of association, this is Thorndike, and it just says a person comes to associate to stimulate if they occur together and respond to both of them, even if one of them would not naturally produce a response. And so you might think about habits that you have. Like you might hear the coffee maker come on in the morning if you're a coffee drinker and you have one of those percolator coffees. They have a certain sound, boop, boop, boop. And that might just right there make you feel more alert in the morning, the law of association. You're associating that sound with the feeling of the coffee, which is stimulant and causing your heart to beat faster and so forth. And so then we have the conditioned or the unnatural, the learned stimulus response mechanism. And so if two stimuli occur together, like a scary loud noise always occurring right when a particular light comes on, then the response to the natural stimuli, the loud noise, will generalize to the unnatural stimuli, the light. So in this example, US, remember, unconditioned stimulus is the loud noise. Unconditioned response, UR, is the fear. The conditioned stimulus is the light. It's not natural to be afraid of a light. That's the learned response. Little Albert is another video that is posted in the lecture. I can't embed it right here, so make sure you watch that. This is Watson's experiment. It seems very brutal to this little guy, although some people who sought him out evidently said he has fully recovered from his experience. So we'll look at that. in class. In this case, Watson is taking it out of the animal realm and creating the same kind of pattern in this little baby, causing this baby to have an associated fear of something that wouldn't normally be fear producing. There's a funny little video I'm also going to show you. If you're at all a fan of The Office, as I have been for many years, then you can see Jim always playing pranks on his colleague Dwight and conditioning a certain response in him, just doing classical conditioning. It's a nice little, cute little video. So we have some examples that, well, let's just point out some human examples. We'll think about these more in class, but you can think about them now. Every time John's mother comes home from work, she yelled at him for something. Maybe she yelled because the house isn't clean, or maybe for homework or something, but she always came home crabby and yelled at him right when she got home. And John began to experience anxiety whenever he heard the house door open. So now we have an unnatural response. House doors opening shouldn't naturally produce anxiety. Getting yelled at naturally produces anxiety. And so in this example, the unconditioned stimulus is the being yelled at, and that leads to the unconditioned response of this feeling of anxiety, right? That's naturally occurring. But the conditioned stimulus is that house door opening. So John has learned that the door of the house opening predicts this yelling, and so in both instances he's experiencing anxiety. After a while, John noticed that he felt anxious even when he heard a car approaching on the street, even before the door opened. Now what's going on? And I think I'm going to save these and ask him in class, or maybe I'll find a similar example. So what we have going on here is second order conditioning, because now remember the sequence. We have the car approaching, then the door opening, then the yelling. Second order conditioning. This now car approaching has become a second conditioned stimulus. Now, when John moved in with his girlfriend in college, he felt his heart jump a little whenever he heard his apartment door open. What's going on here? This is no longer the door of his house with his mom coming in. This is like his apartment door and his girlfriend coming in. What's going on here? Well, we have stimulus generalization. He's linked this anxiety to any time someone comes in and enters his space, the apartment door opening. His girlfriend, though, was really sweet whenever she came home, and, she never yelled at him, and so eventually his heart stopped jumping whenever he heard the door open. What's going on? Now he's learned to discriminate this apartment door from the other door. He's experienced this door opening many times without the yelling, and so we have stimulus discrimination. He now distinguishes between these two doors, and also extinction of his anxiety response, of his conditioned response to doors opening. But just happened once or twice, his girlfriend was really stressed out and came home and did kind of yell at him. It didn't happen often, just once or twice. But he noticed as soon as that happened, as soon as that door opened and she was crabby and laid into him, he noticed that, he had that full-on anxiety response for the next few days when he heard the door open. What's going on here? And here we have spontaneous recovery. And so that means that anxiety, it was down there, it was suppressed, but it was accessible. And when that bad experience came once or twice with his girlfriend, that anxiety shot up once again. It was still lurking there for him. And there are some more examples here. And sometimes I feel silly just reading to you in these slides, so I'm going to let you read these yourself and ask questions. And so just pause it and go ahead and ask questions and see if these make sense to you. So now we ask a question of what if the conditioned stimulus is painful? Could that still produce the same positive conditioned response, like one based on a reward. And so the example here is that every time right before Pavlov fed his hungry rats, he would shock them. So the shock predicts the food. And the question is this: does the rat then salivate in response to the shock alone? And the answer is yes. Even though it's a painful experience, the rat learns that if it predicts food, the saliva comes just when the shock happens. And we might think about a human example maybe being, a child who wants attention from a parent, but the only way to get that attention is to get the parent to yell at them or to make the parent very angry. And so we could maybe learn that when the parent becomes very angry, but they're at least noticing the child, maybe something like that. We might be So we have talked earlier about the trait of neuroticism, the tendency to worry, and we measured this in the Big Five. And so we can think about it in this example as the tendency to react in an emotionally unstable way to given circumstances. And so Pavlov was rated, we often think of this as a trait, and I do also, in particular because of those physiological indicators that we studied in the biology chapter. But Pavlov was able to create this kind of a trait, at least generated experimentally by training. And so what he did is he taught rats to distinguish a bright light from a dim light. And he did that by training them. When a bright light came on, they were given food. And then the rat would salivate, allow itself to be picked up. And if the dim light came on, the rat was given a shot and it would brace for the shock. So the rat learned what was going to predict shock, what was going to predict food. The rat knew what to expect. The manipulation was that gradually Pavlov turned the bright light up and turned the dim light down so that they were indistinguishable. The rat no longer knew what to expect because he could no longer tell these two lights apart. And consequently, the rats were extremely distressed. They would snarl, they would defecate, they would refuse any sort of touch. They didn't know whether they were getting a shock or getting food. Their bodily systems couldn't begin to process whether they were going to get food. This is probably one pellet at a time, very stressful for the creatures. He said this showed an experimental neurosis, experimentally generated a state that's so distressed in this, so anxious and so distressed in response to this uncertainty. And what caused the distress? Well, it is that condition of uncertainty. For all of us, knowing that something bad is going to happen is better than not knowing whether something bad is going to happen or not. And here again, I think of maybe if someone has a parent who's abusing substances, the child doesn't know what to expect when that parent gets home. Is the parent going to be drunk today, flying off the handle, or are they going to be a normal, healthy parent? This uncertainty that the child has to face, we can see how this could, that child, just like this rat, is showing great signs of distress, doesn't know how to react, refusing touch. We can almost see that the same thing might be true of a child who has an unpredictable parent. They have to deal with uncertainty, which is the hardest thing. And just to lay out the study a little bit more, this is the study from the previous page. So first let's look at the pairings. The bright light was paired with food. So the conditioned stimulus is the bright light, the conditioned response is the salivation. The dim light is paired with shock. And so the conditioned stimulus is the dim light, the conditioned response is cowering. So what produced the neurosis? Again, it was that uncertainty, when the rat didn't know whether it should be cowering or preparing its body for food. So this is the parallel human example. The pairing would be the sober mom. the infant gets to cuddle and gets to have food. So the conditioned stimulus is a sober mom. The conditioned response is salivation, relaxation. Another pairing, drunk mom, we have maybe abrupt violent behavior. And so the conditioned stimulus, the smell of booze, and the conditioned response is avoiding mom. So mom drinks vodka and wears perfume. The infant can't tell. Then we might have this kind of neurotic response that could become a personality trait if it happened with enough repetition. And as you might expect, the videos will be on Canvas. So let's conclude. Personality is shaped through learned responses to stimuli in the environment. These responses generate fearful or anxious responses that can occur in response to triggers. A personality trait of neuroticism may emerge if the individual's helplessness in the face of threat persists. And because our brains have particularly strong reception for stimuli that may pose threats, these emotion-driven memories are particularly enduring.